65?
Radicals into
Radicals in trig equations. Is it clear by now what trigonometry is?
Depends.
When you hear the word trig or trigonometry,
Triangle.
triangles are what, but there's something in particular, trigonometric functions.
Cosine, sine.
Sine, cosine, sine, the relationship between sides and angles, right? Okay, just checking. It scares me that only he answered and partly you, but does everybody remember what trigonometry is? Yeah? Okay.
Depends.
Depends on what, love?
If I remember.
Okay, so when you have this, what did you do?
pass the other side.
I passed this to the other side so I could leave the root by itself, and then you would square everything, right, to get rid of the root?
That's -2. So x
Four.
minus
Okay, so you remember this, right? Okay. Now, what if, instead of just x's, you have sine of x minus
oh, you pass the sine of x to the other side?
what lesson was it?
65.
Are we doing the right one?
Okay, there we go. So, I'm sorry, what did you say?
You pass sine of x to the other side?
I passed sine of x to the other side? That would be 1, okay, yes.
You pass the root to the other side.
I'll pass the root because the root is negative. So it's easier if they're all positive. You could pass the other one, in the end it's the same, okay? In fact,
We could cancel the root.
okay, sine of x equals, the point is you have to have a root on one side and whatever's left on the other. And I do exactly the same thing as I did over there, right? Square both of them. And I am left with
Sine squared x minus.
is that correct? Now what?
Then you
You add sine
To the other side and then equal it to 0 again? Okay. Or not?
no
You move
factor it.
Okay, so I have
Oh,
2 sine square of x equals 1. Is that correct?
Pass 1 to the other side.
What for?
So you pass factor it.
I pass the 2 to the other side. I divide everything by 2, so I've got sine squared x equals 1/2. Now what?
You take your
Square root. And I've got
sine x equals square root of 1.
equals plus minus square root of right? And that is what? What angle uses 1 and the square root of 2?
the 45.
The 45. So, but I've got 2 of them, right? Because I've got a positive one and a negative one. So, the root is always going to be positive because it's the hypotenuse. And the hypotenuse is always positive. So I've got, if it's minus 1 square root, where would that be?
It will be below to the right.
Because it's sine, right? And its sign is opposite. So it would be below to the right. Like this.
25.
And the other one is,
Below, no,
and this is
above.
45, right?
Yes.
And the other one is here, because it's positive. And neither that one has 2. This one 45 here, square root of 2 here, right? 1. And there's another one like this. This one, 45, because this one's also positive with the square root of 2. And this one, there's another one here. Isn't there? Because this is also square root of 2, square root of 2, 45. So, I've got 4 angles. What are the 4 angles that I have?
45.
45,
135.
135,
15.
Yeah, you
No, 225.
225.
And 315.
350. Perfect. And that's it. Got it?
Oh my god.
Okay. But when I plug them in, I have to try them out, don't I? I have to try them out in the original one. Here. And when I try them out, what happens? Let's try them out. What is the sign of... We'll try them out here. What happens? Silence.
Kind of 45.
Yes, I know, but why don't you do it in your calculator to see what you get? So it's a participating class. How's that? I'll save you the trouble. I mean, take out your calculators. Give me the sign of 225 equals 1 minus the sine squared of 225. Someone do this.
It's minus 2 squared over 2. That's
How much
sine
is
of
this one?
that. Minus
Negative.
square root of 2 over 2.
Okay, and this one?
And that one I'm doing that one.
I'm sorry, this is taking so long. Just saying. Okay, this one's gonna give you the same thing, but it gives you plus minus because there's a root, right? The problem here is that the minus part is correct, but the plus side isn't. So you can't have something that equals both positive and negative. Therefore, this one doesn't work. Okay? The other one, same thing. The one for 315. So the only ones that you keep are this one and this one. Okay? You got it? Okay, so now let's go on to do you want another one of these, or do we go on to logarithmic equations?
No.
Logarithms? Yeah? Okay. These are always basically the same thing. Except we've got roots. Scary, right? Mary?
Okay.
Uh-oh.
Okay. Now, we have how would we pass that to logarithm? Do you remember the definition of logarithm?
Yeah.
What would you do?
Now you're gonna pass L to the other side.
Okay,
So
that would be your answer, because you're finding the exponent, right? Correct.
So it's gonna be L equals
2n.
Logarithm.
Huh?
Logarithm of
Logarithm base 2, very good. Of?
And
Very good. Okay, so now we're gonna graph. Let's see. Let's do this so you can see it. Take out your calculator so you help me out. Well, you can't do logarithm base 2. Let's do 10 then. So we can do it. Okay. We're gonna have L here and here. Give me let's see, 0, 1, 2, 3, 4, and 5. What would that be?
0, 1.
This would be 10 to the 0? 10 to the 0, 1. 10 to the 1,
20.
1,000.
1,000.
100,000.
okay, so you get it, right? 100,000. And this is a million. It's gonna be hard to graph, but we'll graph it anyway. Now, this one, we've got n here, L. Logarithm, let's try the n. I have to take these, right? I'm gonna take 1, 10, 100, 1,000, 1,000, and a million. And
0.
the L is gonna be 0, 1, 2, I think you figured it out, right? So if I graph it, here, what do I get? I have to put, this is L, this is N, this is 1, 2, 3, 4, 5. And I'm gonna put this by the what? The hundreds? And even then it's not gonna work, but let's try it. 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. Okay. So I've got, for 0, it's 1, somewhere down here. For 1, it's 10. For 2, it's 100. This is 100. For 3, it's 1,000, so it's all the way up here. And so on. So it's gonna look like this. Right? A little bit inclined towards there because it's gonna keep rising, right? Okay. This one, what's this one gonna look like? This one looks 1, 2, 3, 4, 7, 8, 9, 10. So this is 1,000. This is 100. This is N. This is L. And L is 1, 2, 3, 4, 5. For 1, it's 0, so it's here. For 10, it's 1, so it's here. For 100, it's 2. For 1,000, it's 3. And so on. So it's going to look like this. What do you see?
It's the same with this one is going to the left and the other one is going up.
Okay, so they are basically, if I were to draw a line here, if I were to draw like a mirror there, it wouldn't be a mirror, wouldn't it? This way. The other one would be here. Right? So, there's two ways to look at this. You can either draw the exponential equation and then the axis of symmetry and reflect it on the other side, or you already know that it is, you just draw the reflection on the other side. Couple of things that you should know, these two are key. And then you know that it always behaves in exactly the same way. This behaves exponentially towards infinite, and that one behaves exponentially towards infinite, actually not exponentially, logarithmically, and it goes that way, okay? And that's, the only difference is that it might start here. It might pass to the other side. That one will never ever pass to the negative side. Why? Because there's no logarithm of negative numbers, okay? So the points that you are most interested in, it is the 0 and the 1 and the 1, okay? On both of them, the 0 and the 1, okay?